There are 3 easy steps to figure out if a graph or a function is continuous. I'm going to tell it to you right now. A graph is said to be continuous if at a specific point C. This, you need to know, is they're talking about an x value. If the following conditions are satisfied, if f of c is defined, meaning there is a closed circle or it has a value at that x value. That's what it means when it says f of c is defined. Then the second thing is the limit must exist, which again means you have to check the limit from the left-hand side and the right-hand side to make sure that limit exists. And this point is key. It can't just have one of these. It has to have all. The last piece that it must have is that the limit and the value must be equal. So your value has to exist, your limit has to exist, and they have to be the same thing for you to have a continuous function. So this means for a function to be continuous, there can be no gap, split, or missing point for that x value they're asking for, and that the pencil can be moved along the graph without lifting it off the graph. So let's look at these examples that we have here. This whole thing is the f of x function we're looking at. And if we're looking at it at point C, this function would not be continuous because this part goes this way. Then I have to pick up my pen to draw the function going this way. F of c does exist, but the limit of f of c, first of all, from the left is negative infinity, and from the right, it's this y value over here. So the limit doesn't even exist, so therefore it is not continuous. Let's check out the second example. F of c exists. The limit is the same from the left and the right. However, the value and the limit are not at the same y value. Therefore, this other graph is also not continuous. Let's check out these examples. First, let's look at the graph. First, does f of c exist? So f of c exists. It's a line, which means there's a value there. Now let's check the limit. Coming in from the left, it works, and coming in from the right, they match up. Therefore, the limit exists, and the limit and the value are at the same point. Therefore, this graph would be continuous. Now let's look at a function. If you're looking at this function over here, they want to know, is it continuous at x equals negative 3? Well, what happens if you plug in negative 3 to this x value? You will get 0 in the denominator. Therefore, that function is there's no value at negative 3, right? It doesn't exist with 0 in the denominator. Therefore, that function would not be continuous at negative 3. Let's try a couple of examples to figure out if these functions are continuous. Again, the first thing you need to ask yourself is, does the value exist? The value at x, does it exist? 2, does the limit exist? And 3, does the value equal the limit? Let's take an example. X is negative 6. Well, when x is negative 6, what do you have there? You have an asymptote line. So let's go to the first step. Does the value at negative 6 even exist? Nope. So therefore, this guy is not continuous because f of 6 does not exist. Let's try it x equals negative 4. So at x equals -4, we do have a closed-in dot right there. So our value exists. Now we got to check the limit. The limit coming in from the left of -4 is up here at 2. Coming in from the right at -4 is -2. So our limit doesn't exist. So number 2 there is knocked out. Therefore, this graph is not continuous because the limit does not exist. Let's try when x is 0. When x is 0, here's our y value. It's about at 3, so we have a value at 3. Now let's check the limit. The limit coming in from the left comes right up there, and coming from the right, right up there, and they meet. So is the value and the limit at the same spot, at the same y value? Yes, it is. So guess what? For the first time, we have one that, yes, this at 0, the function is continuous. Let's try this one when x is 2. When x is 2, we have a value up there about 3. The limit coming in from the left is down here about 1. Coming in from the right is down here at -4. So our limit doesn't exist. Therefore, this one is no, it is not continuous because our limit does not exist. Now let's check when x is 4. When x is 4, we have an open circle right here. There is no closed-in value, which means we don't even have a value at f of 4. So we can stop right there. It is not continuous because the first condition is not met. Therefore, x at 4, this is not continuous because f of 4 does not exist. So just remember, with continuity, you have to check 3 things. Does the value of the function exist? Does the limit of the function exist? And are they the same y value? All 3 conditions must be met for a function to be continuous.